I'm going to go through example E1B7. It says, 2 point particles with charges Q1 equals positive 30 nanocoulombs and Q2 is equal to a negative 30 nanocoulombs are placed on the x-axis 20 centimeters apart, with the negative particle to the left of the positive particle. A third point particle with charge Q3 is equal to positive 20 nanocoulombs is placed on the x-axis halfway between the first two. What is the force, including magnitude and direction, on the third particle? So the first thing I'm going to do is I'm going to draw a picture. I'm going to draw a picture. That's one of my charges. And this is my second charge. And I know that this is going to be Q1, and I know that Q1 is positive. This is going to be Q2, and I know that Q2 is negative. And then I'm going to put a charge right in between, and that's going to be Q3, and Q3 is also positive. They tell me that the distance from here, Q2 to Q1, that distance is 20 centimeters, and that's also equal to 0.2 meters. And I also know that Q3 is placed halfway in between, so I know that the distance from Q2 to Q3 is equal to 0.1 meters. It's half of the 20 centimeters, and that's the same here. This distance from Q3 to Q1 is also 0.1 meters, or 10 centimeters. Okay, and they also tell me that my charges are Q1 is equal to 30 nanocoulombs. Nanocoulombs means times 10 to the minus 9. So I'm going to write that 30 times 10 to the minus 9 coulombs. Q2 is going to equal a negative 30 nanocoulombs, and that's equal to a negative 30 times 10 to the minus 9. And Q3 is equal to 20 nanocoulombs. And that's the same as what we have up here. So that's 20 times 10 to the minus 9. So if I want to calculate the force on Q3, first let's think about if I have Q3 here, this is Q3, it's positive, and Q2, if I have, or Q1, this is Q1 and that's positive. So if I think about the charge on Q3 due to Q1, I know that because Q1 and Q3 are both positive, that they repel each other. So Q3, the force on Q3 due to Q1, it's going to push it this way. Okay, so this is the direction of the force on 3 due to 1. And now if I also add Q2 into this picture, so this is Q2, and Q2 is negative. So the force on Q3 due to Q2, I know that because they're oppositely charged, that Q3 is going to be pulled towards Q2. So that means the charge on Q3 is going to be F32. Oops. So notice that both of my forces are to the left in the negative x direction. So I haven't drawn my coordinate system yet. So let's say that this is positive x and up is positive y. Okay, so I know both of my forces are going to be to the left. So now I need to, for the force on 3 is equal to the force on 3 due to 1, so we'll call that force on 3 due to charge 1, plus the force on 3 due to charge 2. So I need to find the force due to each of these other particles acting on 3. So let's start with F31. So that's the force on 3 due to charge 1. And my definition, or my equation for force is equal to force is equal to K, and K is given as the Coulomb constant, and that we're going to I'll tell you what that is in a minute. But so my equation is K Q1 times Q3 over R squared. Okay, so now let's write my constant up here. K is equal to 9 times 10 to the 9th Newton meter squared per Coulomb squared. All right, so that's my constant. So I'm going to plug in here. And this R is the distance between Q3 and Q1. So I'm going to call that distance 3,1, just so I know that's the distance between these two charges. All right, so now I'm going to plug in numbers, and I get 9 times 10 to the 9th newtons meter squared per Coulomb squared times the charge of Q is on Q1 is 30 times 10 to the minus 9 coulombs. The charge on Q3 is 20 times 10 to the minus 9 coulombs. And then my R, 3,1, so the distance between these two charges is 0.1 meters. I needed to change from centimeters to meters here because of my units. My K is given in newtons meters squared per Coulomb squared. So I needed to change my units from centimeters to meters so that this would cancel out, and this is squared. Okay, so now when I run through the math, when I multiply this out, I get 5.4 times 10 to the minus 4. And now if I think about my units here, I have, let's write it right over here. So for force, if I just pull out the units, I have newtons meter squared per Coulomb squared on the top times Coulomb over meter squared. So if I want to cancel my units, I have a Coulomb here. So these cancel with this Coulomb squared, and I have meter squared on the top, and I have meter squared on the bottom. So all I'm left with is newtons, which would make sense for a force. So there's newtons. Okay, so we have so far we have the force on 3 due to charge 1. Now we're going to do the force on 3 due to charge 2. We're going to use the same formula, K, my Coulomb's constant, Q 3 times Q2 over R 3,2 squared. Okay, and if I plug the numbers in, you'll notice that they're the same numbers. The only difference is that here my charge for Q2 is negative. So I have 9 times 10 to the 9th Newton meter squared per Coulomb squared times 30 times 10 to the minus 9 coulombs times 20 times 10 to the minus 9 coulombs divided by 0.1 meters squared, because the distance between Q2 and Q3 is the same. So I end up with the same number here, 5.4 times 10 to the minus 4 newtons. Now I didn't add in the negative charge here. I could have added it in here. But on these types of problems, what I like to do is use the calculation just as a magnitude, meaning find the value. And the way I'm going to handle the whether it's negative or positive is here. I know that I figured out what the direction of the force is. So I know that I can add these two forces up, the values of them up, and then my final answer when I have to find direction, I know it's going to be in the negative x direction. So that's why I didn't include a negative, and I'm going to put an x through it here. So the magnitude, the value of adding these two forces together, F3, my final answer is going to be 10.8 times 10 to the minus 4 newtons. And now, in terms of a direction, I know that the direction is in the negative x direction. So I'm going to put a negative in front of here, and I'm going to put a x hat to tell me that the direction is in the negative x direction. Okay, so let me just review that one more time. I'm not adding my negatives into my calculation. I'm using the formula to calculate the magnitude, and I've dealt with the direction and the negatives in the charges. I've figured out what direction the force is pulling. And so both of these, Q2 is exerting a force on Q3 in the negative x direction. It's pulling it to the left. And Q1 is exerting a force on Q3 in the negative x direction because it's pushing it to the left.